So let's see how we can solve a triangle that is not right. We've been using the trig ratios to solve triangles, but we can only use those when we have a right triangle. So now we're going to take a look at something called the law of sines. It's basically a set of proportions that we can use to solve a triangle. And when I say solve a triangle, I just mean find the missing sides and angles. So let's take a look at example number 1. For the triangle ABC, angle A is 35 degrees, angle B is 50 degrees, and side A is 16 feet. Find the remaining angle and sides. Well, the angle is fairly easy. Remember that all the angles in a triangle add up to 180. So C is 180 minus the sum of the other two, which was 85. And so angle C is going to be 95 degrees. So we can draw our picture. And so I'll draw it kind of like that. So there's angle C. And let's see. Make that a little bit longer. Okay. And so angle A is going to be over here because angle A is the smallest angle. And then angle B is going to be up there because it's the angle in the middle of the other two. And so 35 degrees goes here, 50 degrees goes here, and 95 degrees goes there. We also know that side A is 16 feet, and that is the side that is across from the corresponding angle. All right, so now we can use the law of sines to find side B. And so we're trying to find side B. So we're going to put that over the sine of angle B, which we know was 50 degrees. And then we go with what we know from the original problem. Side A is 16 feet, and it goes over the sine of angle A, which was 35 degrees. So now we need to get B by itself, so we're going to multiply both sides by the sine of 50 degrees. So B equals 16 times the sine of 50 degrees divided by the sine of 35 degrees. Now, when you plug this into the calculator, please make sure you are in degree mode. If you are not, you will get the answer wrong. And so when you do that, you end up with B is approximately 21 feet. Now, I rounded to the nearest whole number because in the original problem, side A was given in whole numbers. And so just to use those significant digits. Now we can go ahead and find side C. So side C divided by the sine of angle C, which we found to be 95 degrees, equals, and I'm going to use A again because that was given to us in the original problem. If we use B, then we're going to be slightly off because we rounded that. So we're going to take the 16 feet again and put it over the sine of angle A, which was 35 degrees. And we solve this just like we did for side B. So C equals 16 times the sine of 95 degrees all over the sine of 35 degrees. So you're just going to type that into the calculator, and we get C is approximately 28 feet. And so we have found the missing sides and angle. All right, so now we're going to take a look at something called the ambiguous case. Notice that in this first example that we just did, we were given angle, angle, side. Okay, there's one other of those triangle shortcuts that we can use law of sines for, and that's angle, side, angle. And then there was one more shortcut that we couldn't use in geometry because it didn't always work. And that's what this ambiguous case is. It is the side-side angle case. And if you remember from geometry, we couldn't use that because sometimes we got more than one triangle. So you can see in our notes we have several different situations. Two of the situations give us no triangle that exists. 3 of them give us 1 triangle, and 1 gives us 2 triangles. And so we'll do an activity that will help that to make a little bit more sense later. But let's take a look at example number 3. Solve the triangle ABC where A is 78 degrees, side A is 7, and side B is 35. Okay, so I'm going to draw my triangle. All right, so if angle A is 78 degrees, it's going to be something like that. Okay, and I know that this side is going to be 35, and I've got this side is going to be 7. Okay, and I don't know what any of the other angles are or that missing side, so we're going to use law of sines to figure out what angle B is. So we are trying to find angle B, so I'm going to put sine of B over 35. So with the law of sines, you can use the reciprocal of the proportions if you want to. I try to keep my variable in the numerator on top, so that way it's just easier to solve. And so I know that that is going to be equal to the sine of A, which was 78 degrees, over the side length of A, which was 7. All right, so now sine of B is going to be equal to 35 times the sine of 78 degrees, all over 7. Okay, again, when you plug this into the calculator, please make sure that your mode is degrees, otherwise you will get it wrong. And so we get the sine of B is approximately 4.89. And so if you look at that, how would we solve for angle B? Well, we would do the inverse sine. If you do that on the calculator, it's going to give you an error message because you cannot have a sine value that is larger than 1. So in this case, no such triangle exists. Okay, so we can't actually solve this triangle. Now let's take a look at the next one. Example 4, solve the triangle ABC where A is equal to 40 degrees, side A is 12 degrees, side A is 12, and side B is 14. All right, so I'm going to draw my angle A. I know my lines aren't very straight, that's okay. I know that side B is going to be 14, and side A is 12. And I am going to extend that just a little bit. And I'm going to draw my side A here in a different color. I'm going to make it green. And this is 12. Okay, so now, and actually I want to make that blue because that does not change at all. Okay, all right, so now what we can do is find angle B. Okay, so we can use our law of sines to find angle B. So we know that the sine of angle A, which is 40, over side A is 12, equals the sine of angle B over 14. Okay, and so now we can do 14 sine of 40 degrees all over 12 is equal to sine of angle B. And so we can find out what that decimal is going to be by plugging it into the calculator. And then, so we get approximately 0.7499. And then in order to get angle B, we take the inverse of that. And I'm just inserting the answer because that will give me the most accurate value for angle B. And that ends up being about 49 degrees because I'm rounding to the nearest whole. Okay, and so my angle B can be 49 degrees. Let's take a look. So this will be 49 degrees, and that's angle B. But let's take a look and see if there is another triangle that exists. And what we can do is try swinging that side over. And if we do that, then we've now created an isosceles triangle where two of the sides are 12, which means that this angle here is going to be 49 degrees. And so we can find the other angle B, we'll call that B sub 2, by looking at the triangle. And if you notice, this red line where it connects to the blue line at that 49 degree angle, those are supplementary. So if I take 180 degrees and I subtract that 49 degree angle, that will give me B sub 2. Okay? And so what I get for B sub 2 would be 131 degrees. Now, if I can add that to the 40 degree angle and get something less than 180 degrees, I do have another triangle. So 131 plus 40 is 171. So yes, we can make another triangle out of that. And so we know we can solve two triangles. All right, so the green triangle is B sub 1, and the red triangle gives us B sub 2. So now we can find angle C. Okay, so for the green triangle, angle C sub 1 is going to equal 180 minus 89, because that's the sum of angles A and B. And so that's going to give us 91 degrees for angle C in the green triangle. And then we can use law of sines to find side C. So we have C over the sine of 91 degrees equals, and we use what's given to us, so 12 over the sine of 40 degrees. So C equals 12 times the sine of 91 degrees over the sine of 40 degrees. And so we end up with about 19. Oops. All right, so now let's take a look at the other triangle, the red triangle, and let's find angle C sub 2 here. And so we have 180 minus 40 and the 131. So that's, why did I write 1800? That should be 180. And so that's 180 minus 171, which is 9 degrees. All right, so now we can find side C. So C sub 2 over the sine of 9 degrees equals 12 over the sine of 40 degrees. So C sub 2 equals 12 times the sine of 9 degrees over the sine of 40 degrees. And so when we plug that in the calculator, we end up with C is approximately 3. All right, and so we have found all of the values that we needed for both triangles. All right, let's take a look at the last example. We can find the area of an oblique triangle by using a formula that has been derived using the formula for the area of a triangle and your sine ratio. And so we can find the area of a triangular lot with side lengths that measure 84 yards and 55 yards and form an angle of 115 degrees. And so our yard is something like that. And so we've got 55 yards and 84 yards. And together they form an angle of 115 degrees. So we can use this area formula when we have two sides and the angle that is included. And so we have the area equals 1/2 one of the sides times the other side times the sine of the angle that those two sides form. So that's 115 degrees. And then you're just going to plug that into the calculator. And again, make sure you are in degree mode when you do this. And when you plug that all in, you get approximately 2,093.6, and this would be yards squared. And so that's how you can find the area using your law of sines.